right, so up to this point, we talked a little bit about these normal distributions and what they might look like in terms of a density score, but or density curve, I should say. But moving forward, we want to start thinking about z-scores. They're going to become a very important part of what we're doing in this class. So first things first, we need to kind of get an idea, what is it? What is a z-score? And what a z-score does is it helps us compare spread with our centers, as it will tell us. So a z-score, what it is, it's how many standard deviations a value is, a value or an observation is from the mean. So we're going to use that idea and start to almost standardize the different values we're given so we can see is a certain value further away than other values. So typically these are going to be used, z-scores, when we have a normal distribution. So obviously there's a lot of different types of distributions, skewed, uniform. These are typically used when we get to normal distributions. Now, so let's take a look at a problem. Suppose the heights of these oak trees is normally distributed with a mean of 75 feet and the standard deviation of 10 feet. So we're going to find the z-scores associated with those. So in other words, we're talking about a normal distribution. So the mean is 75 feet and the standard deviation is 10 feet. Right? As we talked about in class Friday, we could go ahead and put that normal curve together with some of our marks here. And this is a pretty straightforward one to use our empirical rule. But the mean right here at 75, and then so 85 as we go up, 95, 105. Obviously, we can also drop below. So we can start to see where some of these might be. So for example, the 82 feet, we're not quite one full standard deviation above. So maybe 82 feet is somewhere right here, right? A little bit above. 67 feet, obviously not quite a full standard deviation below, but maybe sitting somewhere there. 70 feet, again, we're below, but closer. I mean, so we're not as many standard deviations away. And then 96, way up here, just over 2 standard deviations away. So to calculate the z-score, we'll go, so here we are with 82 feet. So a quick sketch, again, just to kind of get the idea here. So our original mean was 75. I've also got this 85. So we want to kind of figure out how many standard deviations we'd be about right there at 82 feet. So in order to do that, we're going to take that 82 feet, and we're going to subtract our mean, 75, and to figure out how many standard deviations away we are, 82 minus 75, we're actually going to divide through by the standard deviation of 10 feet. So 82 minus 75 puts us at 7 over 10. Our z-score here would be 0.7. So we are 0.7 standard deviations away from the mean. That next problem for 67 feet. So again, maybe we take a look at 67 feet. This time, the 75, this time we're sitting somewhere in the negatives, maybe sitting about right here at 67 feet. So the one thing to point out here is that if you're below the mean, we should have a negative z-score because we are negative standard deviations below the mean. I can clean that up a little bit. So let's go ahead and calculate the z-score here at 67 feet. So for that z-score, we'll take the 67, we'll subtract our mean, 75, and divide back through by our standard deviation of 10. So 67 minus 75, we're now at negative 8 over 10 for a negative z-score of 0.8. So we are 0.8 standard deviations below the mean, and that negative helps us to see that. Try a couple more here. So here we go, 70 feet. So here we are again. As our mean is 75. One standard deviation below is 65. So we're looking for basically the value right in the middle of those two. And enough of you are pretty good at math. You've probably already anticipated what the z-score would be if we're right in the middle of one full standard deviation away. We take a quick look. So 70 minus 75 over, again, our standard deviation of 10. Is that negative 5 over 10? Or in terms of the z-score, we are negative 0.5, or we are a half of a standard deviation below the mean. And just for the sake of finishing the problem, here's 96 feet. So one thing we should anticipate, we are above the mean, so we should be looking at a positive z-score. Here's that good stuff, right? Using my empirical rule, I can set part of that up. We are just over 2 standard deviations away. So our z-score, if we could go ahead and anticipate, our z-score should be something just over 2. So take a quick look. 96 minus 75. That's going to be divided by 10. And so we took our observation, subtracted your mean, divided by standard deviation. So now we're at 21 over 10, which is at 2.1, just barely over 2 standard deviations above the mean.